Hello, my name is Thomas Gazort, and this is my explanation video for neural networks, Summit 5, LSTM type models. So, first thing we want to do in this assignment is import all of the necessary libraries, math, NumPy, pandas, matplotlib, and then a bunch of stuff from sklearn that will help us with training, and then Keras that will help us actually build the network. So we do that here. Then the next thing we want to do is download the code for visualizing this airlines data. So we get it from this GitHub repo. And then this down here is all for making this graph right here. So we do that. Get this. This is what the data set looks like, and this is what the graph looks like. As you can see, it is the same, so perfect. So yeah, we want to look at this passengers column. This is what this does. Gets the passengers into this variable, prints the first 5 of the passengers, as you can see here. And then what this does is it makes it a NumPy array of the data type float. So this data set is now the passengers' values as a float and then reshaped. And then you can see the shape. So before the normalization, shape was this. This is the max. This is the minimum. And then we want to normalize the data set using this min-max scalar, which is part of sklearn, I believe. And so we want to make it to this shape. So we get the scalar, we get the feature range between 0 and 1. This is actually the default value, so you don't have to set this, but it might be better if you do. Then we fit transform the data set onto this min-max scalar and then reset it to the data set. And then we say after normalization, the shape is the same, but as you can see, the maximum is 1 and the minimum 0. This helps classify. This just helps with the actual training of the data, because all the data is normalized between these two values. It just makes it easier to learn. And then it's 141. We just want it to be 140. We do that with reshape, and then we can see the shape here is 144, and then comma, nothing. So this is kind of how we're doing the prediction. So we're getting the day 0, which is today. We're putting as the input feature, and then we're making the output label into here, and then we're using that output label as the next day input feature, and then we're predicting the output, and then so on, so on, so on, so on, until we get all of the days. This look back equals 1. That's how many days back. Yeah, so we do that with this function here to generate the training set. So this is basically just putting into code what I was explaining here and what this graph shows. Gets the x and y and says for this range of the set, the y value is I plus look back, which is 1, which would be like this kind of. And then yeah, it pins it, and then we print or we return it. So we get that here. We set the look back equal to 1. We get the data is this, and then we can show this is what the shapes are of the data. So next thing we want to do is do the test train split with a 30% for the test size. We've done this a bunch of times. Split these into 4 values, the training data and the testing data. We're saying data X, data Y, of course. Test size is 30%. We're shuffling the data because we want to pick random data sets through it. And then random state is just the random state. Then we can see the shapes of the training data and the shapes of the testing data. This is 30% of the total. So next thing we want to do is build the LSTM with 2 layers. We want an LSTM with 100 units, and then we want a dense layer with just 1 unit. So We do that here. We make a sequential using Keras. Sequentially, we add the LSTM with 100 units. The input shape is 1, and then look back, which was told to us here. Then we add a dense layer. And then if we look at the summary here, we can see that here. We have a LSTM layer and then a dense layer. The next thing we want to do is compile and train. We set the loss mean to mean squared error, and then the optimizer to Atom. This is down here, loss mean squared error, optimizer's Atom. And then we fit the data with, or we fit the data set into this sequential LSTM. We use the training data, of course. We set the epochs to 10, batch size to 1, and then verbose 2. And then we can see it training here through 10 epochs, and it's trained. So now, next step is to see the RSME, the root mean square error. To do that, we do all of this. So this was given to us, so we just paste this in. This is getting the training and the test data by predicting it through the LSTM model. We invert to the original range. Not actually sure why we do this. I'm not actually sure why we do this, but we do the same thing here and then reshape it. And then we get the root mean squared error. For the training, it's 34. For the test, it's 33. So it's pretty good. Means it's not overfitting or underfitting since these two values are pretty similar. So then we want to plot the what we predicted with the actual labels. So we use this function here. This is what we should be getting, and this is what we get. We put this in here. This all of this is just plotting this legend here. And yeah, as we can see, the ground truths of the X, the predictions of the dots. The predictions follow pretty well on the training set. Little bit worse on the testing set, of course, that's to be expected, and we saw that the error was this on the testing set. So that makes sense. Doesn't follow quite as well, but yeah. And then we have our model of the different days in the airport. So yeah, that's been assignment 5 for Intro to Neural Networks.